Welcome back guys to Mathematical Mindset. So we have this nice math problem here that says x squared minus 3 is equals to the square root of x plus 3. So we have to find the values of x. So right here guys, the first thing we want to do is to simply square both sides. So squaring both sides, this is going to become x squared minus 3 all square is equal to the square root of x plus 3 all square. So this is going to cancel out this, so hence we have this to be x squared minus 3 all square is equals to x plus 3. So right here, the left hand side can be expressed as x squared minus 3 multiply x squared minus 3, which is equals to x plus 3. So expanding this right here, we're going to have this to be x raised to the power of 4 minus 6x squared plus 9 is equals to x plus 3. So the next thing we want to do is to simply rearrange and set the equation to 0. So setting this to 0, we have this to be x raised to the power of 4 minus 6x squared plus 9. So this is going to become negative into x plus 3, and this is equals to 0. Open up the brackets here, we have this to be x raised to the power of 4 minus 6x squared plus 9 minus multiply x will give us negative x, minus multiply plus 3 is minus 3, and this is equals to 0. So right here, collecting like term, this is going to become x raised to the power of 4 minus 6x squared minus x plus 9 minus 3 is equals to 0. And this is going to become x raised to the power of 4 minus 6x squared minus x. 9 minus 3 is going to give us plus 6, and this is equals to 0. So the next thing guys we want to do is to simply apply the rational roots theorem. So applying the rational roots theorem to find the possible roots, looking at the factors of the constant term, which is 6, and the leading coefficient, which is 1. Alright, so right here, the leading coefficient here is 1 and the constant term is 6. The factor of 6 are, we have this to be 1 multiply 6 and 2 multiply 3. So hence, we can say that the possible rational roots are, now we have the possible rational to be plus minus 1, plus minus 2, plus minus 3, and plus minus 6, because this can be also multiplied as minus 1 multiply minus 6, minus 2 multiply minus 3. Okay, so that is how we have plus minus 1 and the rest. So we want to simply test for the possible roots to check which of these roots is going to be equal to 0. So starting for x equals to 1, now the polynomial, which is x raised to the power of 4 minus 6x squared minus x plus 6 is equals to 0. For x equals to 1, this is going to become 1 raised to the power of 4 minus 6 into x, which is 1 all square, minus x, which is 1 plus 6 is equals to 0. 1 raised to the power of 4 is 1, 1 square is 1, so 1 multiply minus 6 is going to give us minus 6, minus 1 plus 6 is equals to 0. 1 minus 6 is going to give us minus 5. Minus 1 plus 6 is going to give us plus 5, and this is equals to 0. So hence, we know that minus 5 plus 5 is going to be 0, which is equals to 0. So therefore, we can say x equals to plus 1 is a possible root. Okay? So this is a possible root, and this can be written as x minus 1, which is equals to 0. So the next thing guys we want to do is to divide the polynomial, and the polynomial is given as x raised to the power of 4 minus 6x squared minus x plus 6. We want to divide it by the possible roots, which is x minus 1. And we are going to do this making use of the long division. Okay? So making use of the long division, this is going to become x raised to the power of 4 minus 6x squared minus x plus 6 divide x minus 1. So x into x raised to the power of 4 is x cubed. X cubed multiply x is going to give us x raised to the power of 4. X cubed multiply negative 1 is going to give us negative x cubed. So subtracting this right here, x raised to the power of 4 minus x raised to the power of 4 is 0. Now right here we have x cubed. So this is going to become 0 minus x cubed is going to give us x cubed. So we have negative 6x squared here minus x plus 6. Alright, so divide x cubed is going to give us positive x squared. X squared multiply x is x cubed. X squared multiply negative 1 is negative x squared. So subtracting this x cubed minus x cubed is 0. Minus 6x squared minus x squared is going to give us negative 5x squared, and we have this to be minus x plus 6. So x divide negative 5x squared is going to give us negative 5x. So negative 5x multiply x is going to give us negative 5x squared. Negative 5x multiply negative 1 is going to give us plus 5x. So subtracting this right here, we have this to be automatically this part is 0. So minus x minus plus 5x is going to give us negative 6x plus 6. X divide negative 6x is going to give us negative 6. Negative 6 multiply x is going to give us negative 6x. Negative 6 multiply negative 1 is going to give us positive 6. So subtracting this, we all have this to be 0. So hence right here, we have that the quotient is given to us as x cubed plus x squared minus 5x minus 6. Okay, so this becomes the quotient. All right, so once we have this right here, the next thing we want to do is to simply apply the rational roots theorem once again. And applying the rational roots theorem, we have that the constant is 6 and the leading coefficient is 1. So looking for the factors of 6, we know that the possible roots for the factor of 6, we've done that earlier. We have this to be plus minus 1, plus minus 2, plus minus 3, and we have this to be plus minus 6. All right, now we have been able to test for x equals to positive 1, which is a root. Now x equals to negative 1 is not a root. You can try that out and see if I'm actually correct. Now x equals to plus 2 actually is not a root. You can try that out, but x equals to negative 2 is a root. So to save much time, I'm just going to go straight into 4x equals to negative 2, and the quotient is given as x cubed plus x squared minus 5x minus 6. So x equals to negative 2, this is going to become negative 2 all cubed, and this is equals to 0. Sorry about that. So we have this to be plus negative 2 all squared minus 5 into negative 2 minus 6 is equals to 0. Negative 2 raised to the power of 3 is going to give us negative 8. Negative 2 raised to the power of 2 is 4. So we have this to be plus 4. Minus 5 multiply minus 2 is plus 10. Minus 6, which is equals to 0. Minus 8 plus 4 is negative 4. 10 minus 6 is 4, which is equals to 0. So minus 4 plus 4 is 0, which is equals to 0. So I've been able to prove that x equals to negative 2 is a possible root. And hence this can be written as x plus 2, which is equals to 0. So right here, following the same process and method we did earlier, the next thing we want to do is to divide the polynomial. Divide the polynomial, and the polynomial is given as x cubed plus x squared minus 5x minus 6. We want to divide this by x plus 2. So applying the long division method, this is going to give us x cubed plus x squared minus 5x minus 6 divide x plus 2. So x into x cubed is going to give us x squared. X squared multiply x is x cubed. X squared multiply plus 2 is going to give us plus 2x squared. Subtracting this right here, we have x squared minus 2x squared, and this is going to give us negative x squared, and we have minus 5x minus 6. X into negative x squared is going to give us negative x. Negative x multiply x is negative x squared. Negative x multiply plus 2 is going to give us plus 2x. So subtracting this right here, this is going to be 0. Minus 5x minus plus 2x is going to give us negative 3x minus 6. So x into negative 3x is going to give us minus 3. Minus 3 multiply x is minus 3x. Minus 3 multiply plus 2 is going to give us minus 6. So subtracting this, all of this is going to be 0, 0. So hence we have that the quotient is given to us as x squared minus x minus 3. And we can easily solve this by using the quadratic formula. Alright, so we're going to solve this using the quadratic formula. All we have been doing right here is for us to simply break down the polynomial to a simpler method in which we can use to solve for the value of x, right? So apply the quadratic formula that says x is equals to minus b plus minus the square root of b squared minus 4ac all into 2a, and we have that a is equals to 1, b is equals to minus 1, and c is equals to minus 3. So right here we have that x is equals to minus into minus 1 plus minus the square root of b squared is negative 1 square minus 4 multiply a, which is 1, multiply c, which is negative 3, all into 2 multiply 1, and x is equals to negative multiply negative is positive, so this is going to be 1 plus minus the square root of minus 1 square is 1 minus 4 multiply 1 is 4. 4 multiply negative 3 is going to give us negative 12. So negative 12 multiply negative is going to become positive 12 all into 2 multiply 1 is 2. Alright, and we have this to be x is equals to 1 plus minus 1 plus 12 is 13 all into 2. Alright, so we have this right here. So hence, we have here to be x is equals to 1 plus root 13 over 2, or x is equals to 1 minus root 13 over 2. So with this, guys, we have been able to get the possible values of x. So right here we have that the roots of x is given us. So let's simply go back right here and see the first value of x. So right here the first value of x is x equals to 1. Now the second value of x is given as x equals to minus 2 right here. So right here we have that the roots are given as x equals to 1, x equals to negative 2, x equals to, now we have this to be 1 plus root 13 over 2, and x is equals to 1 minus root 13 over 2. So these are the roots of x. So the next thing we want to do is to simply verify for us to be able to get the valid solution for x. So right here we have, let's verify. Well, we have the original question right here to be x squared minus 3 is equals to the square root of x plus 3, right? So we are going to verify for x equals to 1. So for x equals to 1, we have this to be 1 squared minus 3 is equal to the square root of 1 plus 3. 1 squared is 1 minus 3 is equals to the square root of 1 plus 3 is going to give us root 4. And we have this to be 1 minus 3 is negative 2, which is equal to the root of 4 is 2. So this is not equal to this. So therefore we say x equals to 1 is invalid. So this is not a valid solution. Alright, so x equals to 1 is out. So let's solve for x equals to negative 2. For x equals to negative 2, we have the original equation to be x squared minus 3 equals to the square root of x plus 3. So x equals to negative 2, we have negative 2 all square minus 3 is equal to the square root of negative 2 plus 3. Negative 2 all square is 4 minus 3, which is equal to the square root of minus 2 plus 3 is 1. 4 minus 3 is 1, which is equal to the square root of 1 is 1. So therefore 1 is equals to 1. So we say x equals to negative 2 is a valid solution. So we're going to say for x equals to 1 plus root 13 over 2, we have the original equation to be x squared minus 3, which is equal to the square root of x plus 3. Okay, so putting this, we have this to be 1 plus the square root of 13 over 2 all square minus 3 is equal to the square root of x, which is 1 plus root 13 over 2 plus 3. So this can be expressed as, so we can easily express this to be 1 plus the root of 13 all square. Now 2 square is given to us as 4 minus 3 is equals to the square root of, look for the LCM here, which is 2. 2 divided 2 is 1. 1 multiplied the numerator is going to give us 1 plus root 13. This is over 1. So 1 divided 2 is 2. 2 times 3 is going to give us 6. So we have this right here. And the numerator can be expressed as 1 plus root 13 multiply 1 plus root 13 over 4 minus 3 is equal to the square root of 1 plus 6 is going to give us 7 plus root 13 over 2. Expanding the left hand side, so this is going to become, if we expand the numerator, we are going to have this to be 1 plus 2 root 13 plus 13 all into 4 minus 3 is equal to the square root of 7 plus root 13 over 2. Expanding this right here, we have 1 plus 13 to be 14 plus 2 root 13 over 4 minus 3 is equal to the square root of 7 plus root 13 over 2. And right here, we have this to be taking the LCM. The LCM here is 4, so 4 divided 4 is 1. 1 multiplied the numerator, we have this to be 14 minus 2 root 13. So this is over 1, right? So 1 into 4 is 4. 4 multiplied 3 is minus 12, which is equal to the square root of 7 plus root 13 over 2. 14 minus 12 is going to give us 2 minus 2 root 13 over 4, which is equal to the square root of 7 plus root 13 over 2. So factoring out 2, this is going to become 2 into 1 minus root 13 over 4 is equal to the square root of 7 plus root 13 over 2. And this is going to become 2 here 1, 2 here 2. So this we are having this to be 1 minus root 13 over 2, right? So this is going to be a positive sign. Sorry about that. It's supposed to be positive and not negative, all right? So 1 plus root 13 over 2 is equal to the square root of 7 plus root 13 over 2. So we have this right here. Now, if you simply simplify this using a calculator, you're going to find out that the left-hand side is equal to the right-hand side. So therefore, we have that x equals to 1 plus root 13 over 2 is a valid solution. So right here, guys, I want you all to test for the last option right here, and the last value of x is x equals to 1 minus root 13 over 2. To be able to show that this is a valid solution or an invalid solution for x, and leave the answer below in the comment section. Alright, so guys, these are the steps in which you can use to solve this type of problem right here. So with this, guys, I'm going to see you in the next video.